Yeah.
That's embarrassing. Make 3. What do they think of you guys? This is wrong.
Yeah, it is.
I'm fine with 3 questions.
What, you were fine with 2?
I'm fine with none, actually.
Oh, none? I hear. Yeah.
Now, do it all. Let me turn off the lights so we can see that.
I haven't turned it on yet. That's why it's hard to see.
Yeah.
You guys getting nervous now?
Super nervous.
Don't get nervous. Don't lose your confidence.
2.5 is the one that's confusing. Yeah.
Exactly.
So that's not what, 2.2 to 2.7?
2.1.
2.1.
1 to 2.7?
7 sections.
Yeah.
A chapter.
And how many questions are we on this?
I don't know. I haven't read it yet.
Procrastinating
It's tomorrow.
at your finest.
It's alright. Don't worry, like I said before, there'll be no shortage of time.
I'm not worried about the shortage of time,
Okay.
but
When there's how many questions, man.
Oh,
You can make it 50 questions. You can take. I let you take all night to do it. How
but
that?
I know if I just like 10 questions, there's a possibility of like 1 question per section or something like that.
Oh, I see what you're saying.
Yeah.
It will attempt to be equally distributed.
I mean, that would be nice if
Yeah,
it was just
we'll
one of
attempt
each.
to do that.
Okay. Thank God.
I can't guarantee. I mean, that's 7 sections. Yeah. There'll be
I
one.
mean, that's a little reasonable. You can practice, a question for each section, just get a feel for it.
And like I said, the written homework that I assigned is a fantastic guide for the type of questions to expect on the
And
exam.
the written homework was what you wrote on the board yesterday?
Yep. What do I look for? Homework?
Oh, that's right. All the calculus class gets to, all the instructors for the calculus gets to write their own exam, but the pre-calcs and algebra don't.
What is that beautiful picture I just drew?
You draw that?
Whatever.
Oh, okay.
So what's the maximum value? Do you understand what the picture says? Can you see it? Do you understand what it's saying?
What's the maximum? So you come all the way across and you go up.
So it has all the bigger values for you. Epsilon is 1.6. Makes sense. If the supposed limit is 13, 1.6 away this way, 1.6 away this way, yield 11.4 and 14.6 respectively. Right?
Do you get
Oh,
Okay. So that's what I was showing you before. It's an epsilon distance away from the supposed limit. And they have L, capital L for the limit of 13. X naught, which is the A in my notation, right? When X is heading towards. X is heading towards 4 from both sides. And how far away is it allowed to be? That's the question. It says, what's the maximum value of delta? How far away will you allow X to be from 4? To guarantee that your function is only 1.6 distance away from 13. The same basic linear picture I drew at the beginning. So what do you think?
Watch, it's 2. I'm doing it.
Point 4.
Okay.
0.4? Yeah, they got it written right there, for God's sake. Right?
Subtract
How do we
the-
get go the
Yeah.
4.4 and 3.6?
How would you get it? Let's say it wasn't written.
Like on the second one, you kind of go along.
So now this one, so remember the function is 4x minus 3. And these are function values. This 14.6 and 11.4 are function values. Okay. So one of the corresponding x values that you would get from a function at 14.6, so you'd have 14.6 equals 4x minus 3, and you would have 11.4 equals 4x minus 3. Right?
Okay, so they're just given to you, essentially.
Yeah. Okay. In this problem, they happen to give it to you, but this is a way to find it, right? This is the maximum function value allowed. This is the minimum function value allowed. Then setting is equal to the function rule, you can derive what the maximal x value and minimal x value should be in that case. Okay. Yeah. We okay with that one?
You said A was X is 0, X naught, what it was?
Yes, their notation they have x naught. You're correct.
Oh.
And that is our A that I used.
Okay.
So question 1 make perfect sense now, right? What am I going to put here? 0.4? I'm getting scared. That was it? Mark 2. Similarly, the function f in the figure satisfies this. Okay, so we know the limit. It says it satisfies this. We know the limit already. As x approaches 3, the function approaches 6. Determine the maximum value of delta satisfying each statement. So if you look, I think we're supposed to just use, I was going to actually figure out the equation that line, but I think you're just supposed to use the picture. So if f of x minus 6 is less than 1, right, meaning the function is a distance at most 1 away from the 6 limit there. This is pointer. So there's the height of 6 that the function is not actually going to attain, but it'll, it's not continuous there, it's going to approach that. So if you want that to be the function at a distance 1 at most away from 6, that means the function would be here at 7 or at 5, right? It'd be trapped there between 5 and 7 according to this part.
Do you remember how?
So what would the delta be then to force that to happen? Well, if the function is trapped between 7 and 5, so then at 7, it's the same logic as a second ago, so you didn't draw it for us. You go down here, this pin is not out, and then there's going to be a 2 here. And when you go to 5, then it's going to be a, what, 4 there? So between 2 and 4, right, are your two possible values. How far away is that from the A value, from the x naught value? Well, if the x naught value is a 3, then 2 and 4 are distance 1 away from that location. So delta should be 1. And we know that already. How do we know that? Because this is a linear function of slope 1, dadgummit. And it says epsilon is 1, so delta should be 1. Pow! See that? Man, this problem is so transparent, it's ridiculous. The last one's we're just kidding. They're not really. They're pretty confused the first time you see them. So now we know this one should be remarkably similar. It should be a half as well, correct?
Half, right? Plug it in.
Okay.
Problem should epsilon equal delta anyway.
That's why that's pow!
What a joke.
Roger, say pow!
I mean, I do that.
No, say pow!
So on the exam, should we just
No,
write?
no. Pow! Nobody's ever done it. No student's ever done it before. Say, pow!
How?
Bow.
All right, I'm gonna grade your exam harder. Better say pow.
Number 3's.
No, you gotta say pow. Just kidding. What?
So on the test, we just write
Number 3 becomes trouble.
that.
Okay, number 3. Okay, I'm getting a little more confident here. Very good. Okay. So similarly, if the supposed limit is a height of 6 as x approaches 5. So now, if I want to be a distance 1 away, so now, unfortunately, you have to read the graph. That's the difficult thing about it. So if you're distance 1 away, they try to make it work really well, then, right? Your distance 1 away is this thing, right? From 6. The function is a distance 1 away from 6 at most. So that puts you up here at 7 and down here at 5. But if you go track back here from 7, it goes down to the number 1, right? Now you could just stop there and say the distance between 1 and 5 is 4, so delta should be 4. If you check the other side as well, it made it work out very nicely. If you go down to a function value of 5, which is the furthest you could possibly be, you can't even actually get that far, but then it's just right up to it. So then you go over here, you can see what the x value should be. It's a 9, which is also distance 4 from 5. So delta should be 4.
I have a different problem.
What?
I have a different problem. We just having a hard time following.
It's just different numbers though, right?
Yeah.
Well, you're saying it's 4 because.
Because they're saying, what should delta be? How far